Hello! In this episode of Finnish machining, we are going to make a disc from mild steel disc. It has two recesses on opposite sides. The other one is a little bit larger than the other, and then there is a 13mm hole through the disc. Well, nothing special about this, but it must be accurate. Yeah. So let's go on with doing some planning how to cut it from the metal slab, and after that it's quite some lathe job. Okay, so the design, which is here. States that the diameter should be 125 millimeters, and since this slab has rounded edges, I give it 10 millimeters more, so it's easier for me. Well, not easier, because now I need to get rid of that in the lathe, but better yet, so 135 millimeters here, and then 135 millimeters here. That's it. Then just draw a line here. Oh, now you see, I made it already too thin. Wow. And these edges then like that, and then 135, if you divide that one by 2, how much is it? It's 60 is 120, 70 is 140, so it's 67.2. 67.2 about there. I need to use my magnifying glasses. 60, oh yeah, it was 68.2. Now it's 0.5, I mean. Oh yeah, about there. And now what I will do, I will scribe here the center point. I will need it in the lathe. This doesn't need to be exactly, but it must be so centered that that I don't lose any material here. So now we have it centered there. Now let's see. And when you are using a center punch like this, let's see. Hopefully it works. This doesn't always work, but hopefully it works. Now you can find your scratches by this. Well, they are really uneven at this time. There you are. There is one. And now I just make it heavier. I need a hammer. Oh yeah, this is Vilnes number 1. Vilnes is a very famous Finnish hammer. And when you punch a hole like this, you don't tap it multiple times. It should be just one strike. Oh, that was not a good one. Okay, that one. Because it jumps off the... Was it a good one? Okay, let's put one more time. Now it's a good one. So it jumps off the hole, and if you punch it again, you will have 2 centers there. And that's not very good idea to have 2 of them. So that's, and now what I want to do, I want to cut the corners. Last time I made this kind of thing, I made the mistake of not cutting the corners. About there. There is my one. There is other. This shortens your lathe time a lot. Okay, then I just put some lines here so that something, can I make this? Oh yeah, okay. 45-degree lines, just cut the corners, you don't want to have these on the lathe. It doesn't need to be exact, but it's good thing to have them like a little bit far away, so you can you don't interact with your work. And then last but not least, this corner. So now, so I will cut off this with angle grinder and then get rid of these corners with the same tool. By the way, this compass, I believe this is a Russian compass. It's very nice. It has a fast acting thing there, and this one you probably know. Everybody knows what this is, and this one especially. I cut it away from the slab, cut corners off to minimize my lathe job here, and then after that I have now dialed this in here. It's inside the center hole I made there. It's now inside 200ths of a millimeter. That's enough. But what I have done a little bit differently here is that when I got it about in the center, I loosened a little bit these jaws, and then I tightened the tailstock so that it pushed the workpiece on the jaws, and then I retightened these and did the final centering for that one. So now it's well, it's as plain, as level as humanly possible here. So hopefully we get it done by just a few tenths of millimeter, I mean the face here. But before that I will make the round part, the outer part, that will be 125 millimeters, was it? Yeah, and well, I have to set up some tooling here so that I can reach in between the jaws here. There is a danger with these jaws. It's very easy to get whacked by these. So therefore I need to be extra careful. Okay, so after fiddling around with different cutting tools, I ended up using this boring bar. It's upside down, and I will run the lathe backwards. So, well, this has two benefits. First of all, it fits into this gap here, and then it also, the chips go down there and don't fly into my shop. So that's very nice. And then I have set up this carriage stop here so that it should stop here before it makes damage. And well, I will run this with, wait a minute, 180 revolutions per minute, so it's quite slow at first, And then we are feeding in 76 hundredths of a millimeter per revolution. It's a medium. And I will now take half a millimeter cut, but at the first cut I will feed in manually just to see what happens. And now I need to have my safety goggles. If this decides to take a flight in orbit, so I'm not totally unprotected. So let's see. The interesting part here is if I can find. Okay, there is our cut. There, that's the cut. I would like to measure if we have what we need. We should have at least 15 millimeters. Let's see now, 15. This is now set to 15 millimeters. Oh man, how can I measure this? I have to measure this outside the camera. Oh yeah, we have 1 millimeter more. Good. Okay. And now I just start to make these cuts. So, the diameter here now is 25.78 millimeters. And I will peel off now the rest in, I will peel it off in 0.2 millimeter steps. And it will be probably 4 steps. So the last one will be a little bit larger. Yeah. Now that dimension should be quite exactly 25.2 millimeters. So that was the last 0.2 millimeters I didn't cut yet. So let's measure this one first. And yeah, I have been practicing with this micrometer. This is actually very good, but you have to do it in a certain way. Well, it's 21. So 1/100th of a millimeter too large. Let's take another measure, just to be sure. But I believe this is This seems to give a really consistent measures when you do it the correct way. So notice I lock it before I take it out from there. Well, 22 this time. Okay, let's assume it's here over 20 millimeters. We need to here over 0.2 millimeters we need to cut away from it now. So well, I'll take just 0.2 millimeters and I'll be happy with that. So this is the finishing cut. Actually we are running this a little bit faster now. It's 400 revolutions per minute, and I have the feed is really slow. It's at the moment about 400 of a millimeter per revolution, and you can feel something in the surface, but it's not. It's actually quite good. So this is the last cut. Let's go. Ooh. Yeah. Well, it scratched some of the rough surface there. Nothing bad about that. And now the surface finish is really, well, this is acceptable. And now let's measure this one more time. Well, there is absolutely nothing we can do if this is wrong now. But, well, it cannot be that wrong. So, I have noticed that I need to rest my hand suitably here, so that when I come here with this micrometer, I have a good resting place, and then I aim this through the center, so that I'm going through the parallel to the the line through the yeah, okay. Let me show you if this focuses there. Hopefully it does. So, well, as expected, it is 1/100th of a millimeter oversize. So now I face this one, and finally something easy. Well, this is we have this thrust body. Is the insert in good shape? Yes, it is. Some shop air there. Oh, okay. Let's see now. This is something I'm a little bit afraid. Well, I think we can do this. Then I lock my carriage here because I want to feed with the compound in this case. Okay. A little bit away from that surface, lock it there. Then feed direction is completely different, and in this case we need quite a lot more speed. I think that one is our. Oh yeah. Okay, now it went there. No, what is this? Okay. Yes. And then I will unlock the compound. Where is my key to unlock? That's it. Okay, there is our 0. Now I will check that the feed is to the correct direction. It's not. Now it is. Let's take 0.2 millimeters. 0.1. Let's see. Well, it's still the wrong direction. See how much we have there. There is something and there is something more. I think we take another 0.1 millimeter and then we go. I want to clean this in one pass. At some point, because the surface finish, as long as the chips are blue, it's okay. But as soon as they stop being blue, I need to speed it up to keep the good surface finish. And I believe we need to speed it up a little bit now. surface. Yeah, I think we nailed it. It's clean in one pass. Good. And it's absolutely smooth. In the center you can feel a lot of surface, but here you cannot feel anything. It's really, and it's a mirror finish. Not a mirror finish, but well, a very good finish. And yeah, so as long as the chips are like this blue, so the surface finish becomes good with this insert, and this is the Cermet insert again. Okay, this is my stub drill, which I will now use to get a good starting hole for my 20.5 millimeter drill. I'm going to drill through this one. This is 12.5 millimeters. And the speed is probably good for this drill. Oh yeah. And I just drill the hole. There you are. 12.5 millimeter hole. Okay, so I have set up my boring bar here. It's the tiny one, and I have also set it up so that we have it going all the way through, and then it stops before we stumble into the jaws. And well, now the next operation would of course be to touch, so that I know where to start. There you are. And as you can hear, it's not concentric. It's not in the exact center. So, 0.25 millimeters away. Okay, there you go. The feed is about correct here. The feed direction is wrong. No, it is correct. There you go. This might squeal. Well, it doesn't squeal. How about that? Okay, there you are. Harm the surface, and oh well, the surface finish is super. So this is a 13H7. Well, it's not a very good accuracy, but enough for this one. So again, this must be pounded in like this, and then we have yet another adapter for this one. So we make a Christmas tree here. Well, Christmas is coming, so we make Christmas trees here. And then we don't dream with such a speed I had there. Okay, I will take this tool out. It might collide with our... Let's see if we have room. Here we have room. And then again we slow down. Quite a bit, actually. That's okay. Lock the tailstock and push it quite far there, and then I put it back. Now we have a 13mm hole there. We should. Okay, now this side we should have a recess of wait a minute, 40 millimeters wide and 11 millimeters deep. So, well, okay, I will first rough it so that the diameter becomes accurate first. And then we have, I leave intentionally something in the bottom so that I can make the depth accurate later on. Okay, so now what I do here is I have set a stop here. And I will now, it's in a convenient place, I just placed it somewhere that I know that I have room. Then I push against the stop and lock the carriage here. So the next step is to align this boring bar tip with the compound. Now it's touching the surface. Okay. Then I go so that I can actually put it into the hole. I zero this dial here. And now I will leave 0.5 millimeter. So 10.5 millimeters. So that was 3, 6, 9, 10 and a half. Yeah, there it is. Now just lock the compound here. Wow. We should be good to go. But I will now check that we have room to rotate here. Yes, we do. And then this should now be freed. Oops. And then I touch. Let's see about the speed. It should be alright. Yes, it is. Yes, I will change this boring bar to a more suitable one when I have enough room to go there. Now, the diameter of this recess is now 39.01 millimeters. So, well, our target is 40 millimeters, so we have a little bit under 1 millimeter to go here. So I will take this in 3 steps, 2 times 0.35, and then I measure it, and after that we should be there. I will slow down the feed now to 300ths of a millimeter per revolution, and then let's take our first 0.35 millimeters. There you go, R, and go here near, and let's turn this a little bit. Yep, there you go. now it should be quite exactly 39.7 millimeters. And the surface finish is super. Let's see now. Yep. Well, it is 39.7 millimeters. Okay. Then it's just to take the rest at 0.3 millimeters and we should be there. Okay. So, yeah. Yeah. Let's see how we end it. Wow, this surface, it's really nice. It's maybe 1/100th of a millimeter oversized. Let me show to you. Hopefully you can see it. Well, there you are. That's the dimension. I cannot get it any smaller. Okay, but now the bottom. I need to plane that first. There is, well, but now we have conveniently the 0 point here. Let's now free the compound, unlock the compound a little bit. And then I lock the carriage here. Okay, I will first scan the bottom here. Oh yeah, there was something. Now this is a little bit because we have backslash here. There shouldn't be a lot, but there is. So, no, that's the correct direction. We shouldn't have any backslash here. Wait a minute. Yeah, exactly. So now, compound. Let's feed in something there. 0.1 millimeters. 0.2. There you are. I will feed this now by hand first. Try to make the bottom plain, because now it's not plain. We need to do something more then, but I want these away from here. Okay. Seems like we need to take, well, maybe 1/10 more. need maybe 1/10, even 1/10 more. Okay. Okay, now actually we were against the carriage stop, so I can go away from there and measure now the depth. So our goal is 11 millimeters here. We should be around 10, I believe. Let's see now. Well, we are a little bit more, but how much more are we? We are there. Tape 10.42. That, and now I put it back against the carriage stop. Let's see now. We should be home now. It should be 11 millimeters. Should be. Let's see. At least it looks really decent. Very good. Well, what can you tell? It's, I think this is 11 millimeters quite exactly. It's, well, it's 11 millimeters. So, here I am, what I have done now, I have turned this around, pushed it with the tailstock tightly to the chuck, and then I have here between the jaws and the workpiece I have copper pieces like this, not to mark the surface, and then I have my test dial indicator here. So, and now my task here would be to, well, dial it in. It's well, all over the place at the moment. So, and this is okay. So this is now low. This is high. So let's see if I can. Yeah. Okay. Now I just check that everybody is tight. That was not tight, actually. Okay. I need to tighten in opposite sides so that I don't move it. Okay. Let's see if we still are loose here. I really want these to be quite tight. Okay. It's dialed in. And, well, Okay, this was about making, well, exact holes in a workpiece. So this one now seems to be, I have been measuring it around, and well, the tolerance in this piece is about 2.5 hundredths of a millimeter. So minus nothing, plus 2.5 at places. The outer diameter is minus maybe, I don't know. It's quite exactly, actually, and you might see there is a transition, but you can feel it, but you cannot measure it. Well, I think this is something like 5 hundredths of a millimeter. And when you turn this kind of a piece around in the chuck, so then you get always that kind of thing. The only way to make this really plain is to put it into an arbor in a lathe, and then you can do this. Also, this dimension here, when I measure it around, there is some deviation. Not much, but there is. So, well, the accuracy, overall accuracy is 1 thou. It's enough for the purpose it is intended to. So, that was this time. Hopefully you enjoyed. And, well, in the next episode we might be working with the infamous rotating welding positioner. I have one idea there what to do. Let's see if that realizes itself, if I can do that. That's really something that I have been thinking about, whether I do it, but let's see. It has something to do about the gears and how to reduce the revolutions. Well, let's see. But this we shall probably see in the next episode of Finnish Machining. Till then, bye!